All right, in our last video, we talked about doing systems of inequalities, graphing them, finding their solutions. Today, we're going to talk about that in the real world aspect of linear programming. So we're going to start with this question here. Now, this question is prompting us for all kinds of pieces. That's not the way it's going to be on a test or quiz. You're going to see something that looks more like this. It's in a word problem, just ready to go, and you're going to have to get all the information. But to get to get this introduction done, I'm going to go ahead and use this one that prompts us for the different parts. So it says the Supreme Shipping Company can load its trucks with both rectangular and cylindrical containers. A rectangular container has a volume of 100 cubic feet and weighs 200 pounds. A cylindrical container has a volume of 200 cubic feet and weighs 100 pounds. Let X denote the number of rectangular crates carried by a truck, and let Y denote the number of cylindrical containers. All right, so the first thing we want to look at here is that they have defined our variables. Usually that doesn't happen. You have to figure out what the variables are. But in this case, they told us X is going to be our rectangular crates and Y is going to be our cylindrical. So everything we use X and Y for needs to come back to that definition. X being those rectangular ones, Y being the cylindrical ones. All right, so our first part says what constraint must be satisfied if each truck has room for at most 4,200 cubic feet of containers. So we're running a shipping company and we want to fill it as much as we can, right? But we only got 4,200 cubic feet of space in the truck, so we have to limit it to that. That's our first constraint, our inequality. So 4,200 is the maximum we can put. Now we can fill it all the way. So I can put an equal sign there. So I can fill it to capacity or I can fill it below. I can't fill it above that though. All right, when we're talking about this cubic feet, we're talking about volume. So this constraint is going to discuss the volume of this truck. And of course, we're going back to these definitions of X and Y. So for our rectangular ones, it says it takes up a volume of 100 cubic feet. And the cylindrical one takes 200 cubic feet. So we would say 100 times each rectangular plus 200 times each cylindrical has to be less than or equal to 4,200 because that's our capacity. So that's one of our constraints. The next one here says what constraint must be satisfied if each truck can carry a maximum of 4,800 pounds. All right, if you've gone down the highway, you've seen those weigh stations on the side. So the truck can't be filled past 4,800. So we've got another constraint. Again, that's going to be on the open side. 4,800 has to be the maximum, so it's going to be on the open side of this inequality. And we can make it all the way to 4,800, so we can get it filled to capacity. Now, our rectangular ones weighed 200 and our cylindrical weighed 100. So this is 200 times each rectangular plus 100 times each cylindrical is going to give me the 4,800. All right, the next part says what additional constraints must be satisfied because the problem involves real objects. Well, since we're shading here below, and this is less than these numbers, at some point X and Y are going to turn negative in the math world. But in this situation, that doesn't make sense. We can't have negative rectangular containers or cylindrical. So we have to include X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. That's going to keep my items from going to the negative. So no negative objects with this X is greater than or equal to 0. In most of the business questions or most of these linear programming questions, these are going to be needed because we do not want to get to negative numbers on this. All right, so we've listed out our constraints. We wrote all of those out. Our next thing is going to be to graph them. And we spent a lot of time graphing system of inequalities in the last video. So I won't spend a lot, but I do want to go over it with the calculator as well, since we haven't done that. So the first thing I'm going to do is solve for y here. So I subtract this 100x to get it to the other side. And so I've got 200y is less than or equal to negative 100x. Did not give myself enough room there. Let me fix. There we go. Now we're going to divide by 200. So we get y is less than or equal to negative 1/2 x plus 21. So we've got it in our y equal form for mx plus b. Now, last time we spent time graphing that, so you should know how to graph it. We would go up to 21 right there, and then we would go down one over to, and then we would connect our points. And there we go. And this would be shaded below because the y is less than or equal to, so we're going to shade below that. But I do want you to know how to do it on the calculator in case you're on the calculator portion and you want to see that. So we go to our y equals. Oh, I don't like the way that looks there. Don't like where it looks. All right. So there it is. We put in our equation. So negative 1/2 x plus 21. Now, the calculator is going to graph the line there. That's what we've always done. Go to our y equals, put that in, it graphs the line there. But this is an inequality, so I want it to shade. Well, I can use the arrow key to get in front of that y equals. So I've used my arrow key. See where my cursor is now? It's in front of it. And so I hit enter and it gives me a little menu. And so I'm going to arrow down here. And this is y is less than or equal to. So we want to shade below. If this was on the open side, we would want to shade above. So use your arrow key to change that there. That is shading above, and that is shading below. So our triangle up at the top, that's above. The triangle on the bottom is below. And so we want this below, so I'm going to hit OK there, and that's going to change it to an inequality. Now, the best thing to always do is match whatever the graph is on your that's given to you. So I'm going to go to my window and match that as well. On this graph, I'm going from 0 to 50 on both the x and y axis, so I'm going to change that to 0 to 50 there. Now I hit graph, and there it is. That's the same thing we have on our paper, this part here, and then our shaded area is this section. All right, so we need to do the same thing for the second one, so I'm going to subtract the 200x to get it to the other side, so that gives me 100y is less than or equal to negative 200x plus 4,800. I divide by 100 and I get y is less than or equal to negative 2x plus 48. So we start at the 48, we go down to and over 1. And some people might say, well, your graph is off, it's not going by 1. That's true, but it's not going by 1 on the x or the y. They're both going by 2's, so the ratio is still the same. So I can continue to go 2 tick marks and down 1 for that purpose. And so there is my line. I'm going to go ahead and connect my points. Pull a solid line again because there is an equal sign underneath it. This one too is shaded below. So my shaded area becomes this one here. I'm not going into the negative because I've got that x is greater than or equal to 0 and the y is greater than or equal to 0. So I would not, that's why we're only using the first quadrant. We didn't even bother to put the second quadrant there because we do not want any of this negative over here. All right, so I'm going to go to my y equals and I am going to go ahead and put the second equation in there. So negative 2x plus 48. I go in front of the y equals again using that arrow key. I get my menu, and again, that's above and that's below. And so this was below, so I'm going to keep that one, and I'm going to hit OK. And when I hit graph, there it is. There's my double shaded area, or quadruple in this case, and that's what we're looking for. Okay. All right, so we've graphed our feasible region, and so now we need our vertices. And so it tells me to call this vertex A, this one B, and this one C. We didn't bother with this one because that's 0, 0, and so if I use 0 rectangular and 0 cylindrical, I got no business. So that's the reason why we're not writing that one down. But A, B, and C are the ones we're going to focus on. And so A is right here at 24, 0. And then B is right here at 0, 21. That was my y-intercept, so I knew that one. The The last one is this one here. And if you're meticulous with your graphing, sometimes it ends up right on the whole number and it's easy to get. But if you're not meticulous on it, there are several different ways we've talked about in solving that. So let's talk about those. If you're on the calculator portion and you graphed it like this, well, we learned how to find that intersection by hitting second trace and then intersect. Enter, enter, enter. It says first curve, second curve, and then intersection or guess. And so there it is, 1812. Now, to reiterate some of the stuff that we also learned before that, I'm going to go ahead and do a couple more things to make sure we reviewed a couple of things before. This is in standard form right here. So we also learned that we can do that with a matrix. So I'll go ahead and review the matrix part here for you. But that's going to give you that intersection point as well, because remember, solving a system is that point where they're both the same exact thing. So for matrices, we hit alpha zoom. This is a 2-variable system, so I'm going to do a 2 by 2. If this was a 3-variable system, I would do a 3 by 3, and so on. So we're doing the 2 by 2. That first matrix is our coefficients. So I'm going to do 100, 200, 200, and then 100. So I've got my coefficients of the x's, my coefficients of the y's. Then we hit the inverse key. And then we do alpha zoom again. And this time I need a 2 by 1 matrix so that I can put my constants. And so that would be 4200 and 4800. And then we hit enter, and there's that 1812. So that was just a review of using matrices to solve systems, just to remind you that there are several different ways you can find that point right there. Now, let's say you were on the non-calculator portion. Well, we can still solve for that. We did the graph, find the intersection if it's on the calculator. We did the matrices if it's on the calculator. If it's on the non-calculator, you can do elimination with this. You could do substitution with these. And so I'll do a substitution just to remind you. So negative 2x plus 48, I would substitute in for the y in the other equation. And so that's equal to negative 1/2 x plus 21. And now it's a 1-variable equation that you can solve. I don't like working with fractions, so I'm going to go ahead and multiply this entire equation times 2 because that's going to get rid of that fraction. So we get negative 2x. So I said I was going to multiply by 2, but I didn't. So let's multiply by 2. That's negative 4x plus 96 is equal to negative x plus 42. So I've multiplied the entire thing times 2. 2 times negative 1/2 gives me a negative 1. Now I have all whole numbers. It's a little bit easy to work with. So I'm going to add this to get it to the other side. So we get 96 equals negative x plus 4x gives me a 3x. I subtract the 42 to get it to the other side. And so I get 54 equals 3x. We divide by 3 and we get 18, which is what we got when we did the intersection and when we did the matrices. So it doesn't matter what method you use to solve, you're going to get the same answer if you do it correctly. All right, so we've got our 3 vertices for linear programming. We had quite a bit of little review session there, but we're going to keep going now. All right, so it says, suppose the Supreme Shipping charges $50 to ship a rectangular crate and $60 to ship a cylindrical container and wishes to maximize its income. There's that maximize profit. So that is the purpose of the problem, to make our money. So since that's the purpose, that is our objective function. This is an equation, so it should be an equal sign. And so we get 50 times each rectangular plus 60 times each cylindrical. Notice that we're still using the same exact variables and they should make sense in the problem. So $50 times each rectangular plus $60 times each cylindrical will give me my profit, which is what that says. All right, so now we're going to plug in our points into our objective function. And so I start with A, and so I get 50 times 24 plus 60 times 0. And so we're going to multiply 50 times 24. And so that gives us $1,200. Not bad. All right, now we're going to do B. And so I'm going to plug in, we've got 50 times 0 plus 60 times 21. And so that gives us 1260, a little bit more money. So that's a better packaging situation. All right, for our C now, we're going to do 50 times 18 plus 60 times 12. And that gives us $1,620. Well, if I'm running Supreme Shipping, this is where I want to be. This is where I'm going to make the most money. So Supreme Shipping should ship 18 rectangular because that's what my X was. Remember, X is rectangular, so that's what I want to ship is 18 rectangular and 12 cylindrical to maximize profits. There we go. So we finished that problem. That had lots of parts. So on a test, it counts for a lot of points because there's a lot of things you need to do. So let's just reiterate. Step one, we define our variables. This problem did it for us, but that should be step one is define your variables. Step two, write out your constraints. So the system of inequalities needs to be written using the variables you defined. Step three, you want to graph those. So graphs over here. Graph the system of inequalities or constraints in linear programming. Step four, find those vertices because you need those vertices. And then plug those into the objective function and determine where your maximum minimum finds, and then answer the question. Lots of steps. All right, now we're going to do one like the one that you will see on a test or a quiz because they're not going to prompt you for all of that. So we need to think about it from the whole word problem point of view. So here we go. Each quart of the regular skin lotion that Harold makes contains 2 cups of oil and 1 cup of cocoa butter. Each quart of his extra rich lotion contains 1 cup of oil and 2 cups of cocoa butter. Harold makes $10 profit on each quart of the regular lotion and an $8 profit on each quart of the extra rich lotion. If he has 12 cups of oil and 8 cups of cocoa butter on hand, how many quarts of each type of lotion should he make to maximize his profits? What would his profit be? There's a lot going on in that problem, so let's start breaking it down. First step is to define the variables. That usually comes from this bottom part right here. Our variables are our unknown. What do we want to know? We want to know how many quarts of each type of lotion should he make. So that's my variables. So X will be the regular lotion. Y will be the extra rich. I've defined my variables. First points awarded. All right. What is the purpose of this problem? Well, this purpose of this problem is to maximize his profits. So my objective function, which is an equal sign because it's an equation, is about the money. Still using these variables right here. Well, I make $10 on each regular lotion, so 10 times the regular lotion plus 8 times the extra rich is going to give me my profit information. So now we've written the objective function. All right, our constraints comes from what is stopping Harold from making tons of this lotion and selling tons of it? Well, he only has 12 cups of oil and 8 cups of cocoa butter, so that's stopping him. So that's what the constraints are. It's what's holding us back. What do we need to keep in mind? So we only have 12 cups of oil, and so that's going to be on the open side of the inequality. This is the maximum. Now we can use all 12 cups of it, but we can't use any more of that because we don't have any. So this is going to be a constraint on the oil. Still going back to these same variables each time. So our regular lotion contains 2 cups of oil. So 2 cups of oil times each regular lotion. Our extra rich lotion takes 1 cup of oil. So 1 cup of oil for every extra rich. And you should be able to read it back to yourself, and it should make sense like that. So 2 cups times each regular lotion plus 1 cup times each extra rich has to be less than or equal to 12. That's what it says up there. Now there's a restraint or constraint on the 8 cups of cocoa butter. So now we need one for the cocoa butter. And so our regular lotion takes 1. So 1 times my regular lotion plus 2 times my extra rich lotion. Like all products, we can't have negative lotion. So we do need our regular lotion to be above 0 and our extra rich to be above 0. So we've got our constraints now. We're ready to graph. You can graph with the intercepts. You can graph by solving for y, however you want to graph. Go ahead and pause and graph this. All right, this is the graph that you should have gotten right there. Now let's talk about our vertices. So 0, 0, that's an easy vertex right here, but that means he has no lotion, and so he made 0 money. Not so great. All right, our next one here, 1, 2, 3, 4. So we've got 0, 4. That's an easy one to get. 1, 2, 3, 4, 5, 6 is right here. That's an easy one to get, so 6, 0. The hardest one is going to be this one where they intersect. And so just to do it one more time, we'll go ahead and practice putting that matrix in. So alpha zoom, and I want a 2 by 2, since this is a 2 variable. We're going to put in our coefficients. Then we hit, can't see that. Oh, that's terrible. There we go. Now we hit our inverse key, and then we hit alpha zoom again, and this time I want a 2 by 1 for our constants. And so our constants were 12 and 8. So 12 and 8. And there it is, 5.3 and 1.3. Now I've got my vertices. Time to plug it in and see how much money I'm going to make. So X and Y, so when I plug in 0 for X and 4 for Y, I get $32 in this case. If I plug in my 6 for my X and my 0 for my Y, I get $60 in this case. And then if I plug in 5.3 in for my X and 1.3 in for my Y, I get $63.40. All right, so that's what happened mathematically. Now we are smarter than just taking the information given there. We need to think through the reasonableness of this problem. So it is saying for him to sell 5.3 bottles of the regular and 1.3 of the extra rich. Well, you can't really sell 0.3 of a bottle, so that doesn't make any sense. Now, that's this point right here. We can go to 5 and 1 because then we would have whole numbers, so he could sell 5 and 1 of the extra rich. But if I plug that in, I plug in the 5 for the X and I get 50 and the 1 for the Y and I get 8. So this is $58. That's not the max because this is bigger right here. Remember, the max only happens at the vertices. So this point is not helpful. It is a solution. I can do that, but it's not going to be the max. The max only occurs at these vertices. And so the solution would be this one right here. Harold should make and sell 6 of the regular lotion. For the maximum profit. All right, one last one we're going to do here together. It says Colton is planning a green roof that will cover up to 600 square feet. He will use 2 types of plants, the blue lagoon sedums and the red sedums. Each blue covers 1.2 square feet. Each red covers 2 square feet. Each plant costs $2.50, and Colton can spend at most $1,000. Colton wants to help control air pollution. He wants to maximize the amount of carbon dioxide the plants on the roof absorb. Each blue absorbs 1.4, and each red absorbs 2.1 pounds of carbon dioxide per year. What is the number of each plant that he should plant? Step one is to define my variables. Usually comes from the question, what is the number of each plant he should plant? So X is going to be my blue lagoon. Y is going to be my red. I've defined my variables. All right. The objective of this is to maximize his carbon dioxide absorption. So my objective function, the one with the equal sign, is going to see the maximum. So it tells me the blue is 1.4, so 1.4 times each blue, and the red is 2.1, so that is plus 2.1y. That's my objective function. Now, the constraints comes from what is keeping him from saving the planet here with all the carbon dioxide absorption? Well, he only has 600 square feet on his roof, so he can only plant that many, and he's got a limited budget of $1,000. So let's talk about that. That's going to be his maximum space. That's going to be his maximum budget. So when we talk about the space, it says the blue is 1.2, so 1.2 times each blue, and the red is 2, so 2 times each red. So 1.2 square feet times each blue plus 2 square feet times each red has to be less than or equal to 600. For the budget, they are each $2.50. So $2.50 times each blue and $2.50 times each red. And of course, we want no negative items. So my x's have to be greater than or equal to 0, and so do my y's. Time to graph those. Again, graph them with the y and x intercepts or graph them with the slope intercept form. However you think is easier. Go ahead and pause the video, graph it, and see if you got it correct. I'll go ahead and do the same. All right, that's what you should have gotten for the graph right there. So we're ready to pick our vertices out. And so the first one, of course, is 0, 0, but that means he planted nothing, so it's not that important. All right, our next one is 0, 300. That gets us our y-intercept one right here. Then we've got run right here. This one happened to be right on the whole number, which is really nice, 250 and 150. If your graph wasn't really accurate and you couldn't be sure that was the number, remember to do it as a matrix or as an intersection or as substitution or elimination to find this point. Then the last one is 400 and 0. So now we've got our vertices. It's time to plug those in. So we're going to take this and plug it in for x and this one for y right in our objective function. And so that is 630 pounds of carbon dioxide. And so now we do the same thing for the other one. So 1.4 times 250 plus 2.1 times 150. That gives us 665 pounds of carbon dioxide. And then we're going to do the same thing for our last one here. And so that gives us 560 pounds. So we can now look for our biggest value. These are all whole numbers, so they're all reasonable. This right here is giving me my maximum carbon dioxide absorption. So Colton should plant 250 blue lagoons because that's my X value and that's what we defined our X value as. And 150 red for the maximum CO2 absorption. All right, that was 2 full linear programming problems that we did from the beginning. So quick summary, step 1, define those variables, figure out what your objective is, figure out what's holding you back from that objective. That gives you your constraints, graph the constraints, find your vertices, plug them into your objective, and find what's the reasonable answer there. Lots of steps, but I know you can do it.